some positive effect. Okay, so what it means is if you now have some running nose, then you take a drug, okay, then the running nose is stopped. Or right now you have a headache, then you take a drug, then the headache is stopped, okay. Or right now you feel sad, okay, after you take a drug, then you feel happy. So actually, drug will always give you some positive effect. However, if you somehow take the drug, okay, so without any medical prescription, or you try to abuse on a drug, okay, then that will become an abuse the drug. So for an abuse the drug, so it will be leading to some negative effect. But the most things that is in a problem is most of the abuse the drug, they are a certain kinds of illegal drug. Okay, so once okay you find someone that is having the drug addiction, maybe the first impression that would be a certain kinds of illegal drugs. Okay, some of the illegal one. Okay, so because of the illegal drug, it contains the habit formating property. And if someone take it, then it will be existed with the dependency. So therefore, people will keep on abuse it. Okay, but it doesn't mean that you cannot abuse a legal one. Okay, so you still can abuse on the cough syrup, you still can abuse on the paracetamol, but most of the time that we see, okay, for the abused drug, they are the illegal one. So therefore, for our goal in the drug analysis, okay, so our goal. So when you find some drug sample at the crime scene, so most importantly, we would like to see whether the drug that you find, okay, that is the legal one or the illegal one. So actually, the penalty will be quite in a different. For the legal one, actually, that is not even for a penalty. But for the illegal one, depending on the amounts that you find, okay? So small amounts may be just 藏毒. So if it is in a large amount, then they will be 贩毒, okay? So actually, that will be our goal of the drug analysis. So in terms of the drug analysis, so before we really conduct the analysis, so we have to do some drug sampling. So in terms of the sampling, that will be quite straightforward. So most of the drugs that we have would be in a form of the powder, tablets, or certain kinds of capsule. So they are quite small in size, okay? So in order to avoid the leakage of the sample, the loss of sample, so most of the time we will make use of the drugness flow, okay, in order to keep the drug sample. But keep that in mind, okay, if right now you are having some volatile drug, then you have to put it inside the airtight container. But most of the time, okay, it will be just simply some powder, some tablets, or some capsule. So you would like to put it into the drugness flow. So during the sampling, there is one thing more, that is to seeing the effect, okay, so the behavior of a person who have been taking the drug, okay, because the effect right here would be a very important background information in order to help us to narrow down the number of possibility. So last time I have already showed you 4 different kinds of drug, okay? So we have the narcotic drug, we have the depressant, we have the stimulants, we have the hallucinogens. Actually, the effect, okay, would be somehow quite different, okay? So just seeing the effect or the behavior of the person who have been taking the drug, then actually you may narrow down the possibility to say, okay, the drug, okay, may be a stimulant. The drug may be a depressant, okay? Actually, that will help us to set up an appropriate protocol for the analysis. So after we have the sampling, then we could come back to the lab, okay, to start our analysis. So in view of the drug analysis, we have 5, okay, steps there. The first step that is related to the visual examination. So for the visual examination, we do have two important things, okay, to visualize, okay, to be seen, okay. The first one would be the drug itself, okay. For the drug itself, depending on the size, depending on the shape, depending on the color, so we try to deal with a grouping. So we try to group the drug, okay, so different kinds of drug together. Because what we assume, okay, after the grouping, so each of the drug sample will be an individual sample, okay? So that will be an individual sample, okay? So otherwise, if it is a mixture or it would be another problem, so what we try to say is, after we do the grouping, okay, so we believe that that will be an individual sample. The other kind of things that we need to deal with the visual examination, that is the plastic bag, okay, that contain, okay, the drug sample. So by the use of the plastic bag, that will be used for the comparison purpose. So meaning that we could be able to check back for the origin, okay, so the drug manufacturer or the drug seller. Because by the active ingredient or even by the diluents of the drug, okay, so actually more or less for different manufacturer, for different drug seller, they are the same, okay. So actually we cannot make use of the drug itself, okay, to check back for the origin. But the plastic bag which contain the drug, okay, can do that. Because of the plastic bag, we have the individual characteristic on the exclusion mark. So actually that will be help us to link up the plastic bag, okay? And for the class characteristics, so it could be the size, the appearance, the refractive index, the density, or even the chemical composition of the plastic bag. So actually we can be compare to the drug manufacturer in order to know about the origin of the drug, okay? So after we have the visual examination, okay, so by default we know about the origin and now we have the individual sample, then we try to go through the screening test, okay. So by the use of the screening test, we further narrow down the number of possibility. Because by the background information, it just narrow a bit, okay, we have to further narrow down the number of possibility before we can proceed. So by the screening test, we have two main types. So the first type will be the color test. So in terms of the color test, okay, that will be simple to be say of we have the drug sample added with some specific reagent, then will be given out with the color. So with the presence of the color, then we can be say to be positive or negative. So for the color test, okay, so last time I have mentioned to you different kinds of color tests. So we have one preliminary color test. So we have 5 primary color tests, and we have a lot of secondary color tests. So for the preliminary color test, basically, we just try to differentiate out the drug, whether that is an alkaloid or not, okay? So therefore, the test that we have, that is the Mayer's reagent. So if it is a kind of alkaloid, then you will be seeing with the creamy white precipitate. So if it is not, okay, then there will be a negative result. For a positive result on the Mayer's reagent, so that is the alkaloid, so it could include the opium derivative, so that will be the morphine, heroin, or the codeine, or even the amphetamines, okay, or the cocaine, okay. So therefore, we can group, okay, those kind of drug into one side, okay. If it is a negative, then we move to another side. So therefore, for the Mayer's reagent, if it is really positive, so we can be making use of the Marcus reagent. So in the primary color test, okay, to check, okay. Because for the Marcus reagent, if it turns purple, then that will be the opium derivative. So if Marcus reagent turn brown, so that will be the amphetamines or the methamphetamines. So if the Marcus reagent turn black, okay, that will be the ecstasy. So if it is negative, then we can go ahead to check with the Scott reagent. So Scott reagent, it is another kind of primary color test. So under the acidic environment, so that will be checking for the cocaine. So under the alkyl medium, that will be checking for the ketamine. So we will be seeing a color changing sequence. Okay, so from blue, pink, and then we have the pink over blue. Okay, so we will be seeing a color changing sequence for the Scott test. So right now, if you have the Mayer's reagent negative, then we move to another side. For example, we can be making use of the Daly-Copenhagen reagent, okay, for the checking of the barbiturates. So that will be purple for a positive result. Or we can be making use of the enriched reagent for the checking of the LSD. So for the LSD presence in the enriched reagent will also be purple. Or even if you now have the plant material, so you could be able to making use of the quinoline reagent to check for the THC, so that is the marijuana. So you will be seeing purple and then purple over purple, okay, for a positive result. So that will be one preliminary color test, and we have 5 primary color tests. Actually, by the use of the preliminary one, then making the whole color test approach will be much more systematic. Instead of you have right now 5 primary color tests, you do it just try and error. So if now, okay, you do have a lot of sample left behind, then you could be able to check with the secondary color test. So for the secondary color test, it will be having 2 kinds of purpose. The first purpose will be the further confirm, okay, the result of the primary color test. So last time I have already showed you some example. For example, after we identify that is the opium derivative using Marcus reagent, actually we can be using the Marquis reagent. Okay, so the Marquis reagent to check for the opium derivative again. Okay, then it will be turning in green. Or even for the quinoline reagent, so that will be the THC, the marijuana. Actually, we can be further making use of the KN reagent. So if it turn into a red color, then it further confirm that is the THC. So another purpose by using the secondary color test, that is to further differentiate what it is. Okay. For example, by using the Marcus reagent, now it turned brown. So it could be the amphetamines or the methylamphetamines, but we don't know which one is which. So therefore, we can be making use of the Simon's reagent. So if the Simon's reagent turn blue, then there will be the methylamphetamines. If the Simon's reagent remain no change of the color, then there will be the amphetamines. So actually, I have showed you different kinds of secondary color tests. So for those kind of secondary color tests, either it will be used to further confirm the result of the primary one, or to further differentiate what kinds of drugs are there. So apart from the color test that we can use for the screening purpose, actually we have another one that is the microcrystalline test. So for the microcrystalline test, so we are now having the drug, and then we try to add in some reagent, and then right now crystal will be formed. So with the presence of the crystal, so for the size or the shape, then we try to observe it under the dark field microscope. Okay, so that will be the dark field microscope. Okay, so in order to have a better contrast, okay, then by the crystal, so obviously we could be able to know what kinds of drugs are there. So by compare the 2 different kinds of screening tests, so color test will be somehow preferred, and the microcrystalline test may not be that preferred. So obviously, observing color will be better than observing crystal. Okay, so using your eyes instead of using a microscope. And then last time I also showed you a reason on the reagent that we are using. Okay, the reagent that we use, okay, for the microcrystalline test may be a little bit expensive and also a little bit harmful. So therefore, most of the time, okay, we prefer to apply the color test, okay, for the screening. So after we go through the screening, then we try to go ahead for the confirmatory test. But before that, we have to do some sample pre-treatment, okay? Because for the drug, okay, so most of the time that is the powder, the capsule, or the tablets, okay, so that will be a solid. So we have to prepare the sample solution. So we have two ways, okay, in order to prepare the sample solution. So either you make a complete dissolution, so you try to dissolve the whole drug sample into the solution, okay? Or if you are afraid of the matrix effect, then you may be working on the simple extraction. So try to isolate a little bit, okay, so of your analyte away from the matrix to avoid the matrix effect, okay, then that will be done by the simple extraction. So when the sample solution is ready, then we can go for the confirmatory test. And at the same time, please make sure that we have to do it twice, okay, so that will be a retest there. So in order to really confirm, okay, so the respective identity or even for the amount, okay. So last time, just showed you a little concept, okay. So for the confirmatory test that we use at the very early beginning, it will be better to be non-destructive in nature so that we can retain our sample, so that we have sufficient sample to perform the retest. For the retest, destructive or non-destructive, it doesn't be a matter. But we prefer, okay, for the first confirmatory test, okay, to be non-destructive. Okay, so that is what we have been talking about last Tuesday. So any questions or problem at this moment? So before we start to talk about the details of the confirmatory test. So most of the confirmatory tests or all of the confirmatory tests, they are the instrumental analysis. So any questions or problem at this moment? Okay. Or non-destructive in nature. And I will also put a little bit details, okay, on somewhere we have to pay attention, okay, while we are doing applying those kind of technique in the drug analysis. So for the principle and the theory, actually you have been learned in the analytical spectroscopy, or you learn it in the separation science, or if you have been taking the mass spectrometry, okay, so in the semester one, so you will learn about, okay, so those kind of mass spec already. So right here, I will not trying to give you a lot burden, okay, on the principle and the theory or even on the instrumentation. Okay, so let's get started. So for the confirmatory test, for those kinds of instrumental analysis, naturally, chromatography, okay, so would be one of the main technique, okay, that we can be applied. So for the chromatography, basically, we have the TLC, we have the GC, and also we have the HPLC, okay? But in view of the drug analysis, most likely we will apply TLC and the GC only, okay? So for the chromatography, mainly we will apply TLC and the GC only. So you can ask, okay, so why the HPLC has been skipped, okay? Because for most of the drug sample, they are thermally stable, so they are quite volatile, okay? So they won't be degrade or decompose inside the GC oven. So actually, in order to gain the throughput of the analysis, okay, so actually we try to make use of the GC, okay? Because most of the drug, okay, they are good enough, okay, to be subjected for a GC analysis. then no need to go back for the HPLC with lots of solvent at the mobile phase, and also you have a quite a long running time, okay? So therefore, TLC and the GC would be the two kinds of technique in the chromatography that we will use for the drug analysis. So for the TLC, I believe you know, okay, what it is. So normally we are having a substrate, okay, so that could be a paper or even some thin layer of the polymer. Then at the below, we would like to draw a line, and then we dip our sample spot at the bottom, and then at the below, we will immerse it into the solvent, okay, that will be adding as our mobile phase, so that different components in the sample will be migrate upwards, and then they will be able to be, let's say, separate. So with the separation, what we could be measured, that would be the distance of travel. So distance 1, and then that would be the distance 2, okay? So depending on the distance of travel, okay, actually, we could be able to calculate the retention factor, okay? So that will be the RF value. So you can be imagine that different component, different compound, they will migrate differently, okay? Because it is a specific unique interaction between, okay, the solvent as the mobile phase and also the thin layer substrate there, okay? So therefore, the migration will also be unique, okay? That means, okay, based on the distance of travel, so we could be able to making use of it to identify what kinds of compound, what kinds of substance are there. So for the GC, you know, okay, we are running with the GC for a chromatogram, okay? So that will be signal versus the time. So once you inject something to the GC, then you will passing through the column. So the analyte will be interacted with the column, the stationary phase. If it interact a lot, then it will be eluted out at a longer time. If interact just a few, then they will be eluted out quite fast, okay? Then what you will be see is the sample, those kind of substance will be being separated, and then they are being eluted at different time, okay? Then you can be seeing that those kind of interaction between the stationary phase actually will also be unique, okay, towards different kinds of substance, okay, mainly, okay, if you are saying the GC, maybe that is the C18, then that will be the polarity, how non-polar it is, okay. For a much more non-polar guy will be eluted out at a longer retention time, okay. So therefore, based on the retention time, okay, so we can be able to identify what it is, okay. So this is quite straightforward, okay. I guess most of you learn it somehow in the university level already, okay, in the undergraduate level. So in terms of the quantification, so basically for the TLC, you cannot perform any quantification, okay, because you can be just seeing how they migrate, but you do not have any tools, okay, to recall, okay, on the concentration. But for the GC, based on the pit area, okay, so each of the pit, okay, you will have the pit area. So if you have a lot of sample, okay, a lot of analyte, then the pit area will be larger. So if you have just a few, then the pit area will be somehow smaller. So with the calibration curve, so you can be quantifying, so how much are there. So that will also be straightforward, okay, so you should have been learned it. So in terms of the destructive or non-destructive in nature, so for the TLC, that would be non-destructive, okay, because you can be cut out the spot, okay, so on the thin layer substrate, then you can be dissolve back, okay, your analyte in order to do some further analysis. So actually, you can make use of the scissor to cut out the spot, and then you redissolve out the analytes. Okay, so that will be non-destructive. And for GC, just depending on what kinds of detector that you are using. For example, if right now you are using the FID, okay, so film ionization detector, So that will be destructive in nature, okay? Because for the flame ionization detector, that will be the combustion process. So everything will be just being burned. But if you are now making use of another detector that is the TCD, so that will be the thermal conductivity detector. So actually that will be non-destructive. You can take the analyte back, okay, in order to do some further analysis. Therefore, for GC, just depending on what kinds of detector that you are using. For example, like you still can have the MPD. So MPD could be destructive, or you now have the ECD. So ECD will be non-destructive in nature. Okay. So therefore, just seeing, okay, so non-destructive versus destructive. But as I already mentioned, the first confirmatory test that we prefer, okay, should be non-destructive in order to retain our sample. So right now on the slide, actually there's one more thing, okay, for you to pay attention. So right now for the identification that we have, that is said to be tentative identification, okay? The identity, it is not confirmed or not that absolute or not that 100%, okay? So the chance of having that identity, okay, that will be really high, but it's still to be tentative. So why is the case, okay? Or maybe before I go forward, okay, so just simply put up tentative identification. So that will be T, okay, so there. So because right now, when we have the separation on the thin layer substrate, or even we have the separation on the GC column, so actually that will be a certain kinds of, let's say, chemical property. So that will be the polarity. So if you are now having some similar kinds of compound, if their polarity, this is really close. So actually they will have a similar distance of travel. At the same time, they will have a similar retention time. So therefore, if it is really similar, okay, so because of the measurement uncertainty or the shift a little bit of the retention time or the distance of travel, actually you may still have the risk, okay, to misidentify, okay, so what it is. So therefore, according to the retention factor, according to the retention time right here, that is specific, okay, it is close to unique, but it is not 100% unique, okay. So therefore, we say that the identification that is tentative only, okay, because right now we don't be guaranteed that it must, okay, be that substance, or it may not be that, okay, so compound, because what we just based on, that is the polarity only, okay, maybe different compound, they share similar kinds of, let's say, polarity there. So quite similar retention time, quite similar distance of travel, then we may still have the risk, okay, to misidentify what it is. But the case for that may not be that high because we are doing some optimization, but still, okay, we have to pay attention. It may not be 100% sure. Okay, so right here, I want to further give you some more details, okay? So in the TLC and the GC, okay? So for the TLC, normally we try to apply it on different kind of drug, but most commonly we try to apply it for the analysis of marijuana. Okay, so marijuana, that is the cannabis, so that is the daima. So why, okay, thin layer chromatography, that is quite common to be used for the analysis of marijuana. So mainly because, okay, inside marijuanas, it is not only having one kind of ingredient. The major ingredient that we concern, that is the THC, okay, so the tetrahydrocannabinol, okay, so that is the main active ingredient that why the government will ban the use of the marijuana, okay. But inside the marijuana, we still can be seeing quite a lot of different kinds of compound. So we can be seeing the CBC, CBD, or even the THCV, the CBG, CBN, or even the cannabinoid acid. So actually, by running a marijuana, so we can be able to seeing right here 1, 2, 3, 4, 5, 6, and 7. So 7 spots, okay, will be there. So what I mean is, if you now have a sample that is somehow we suspect that it will be a Mara Luna. So even after you conduct the analysis, you could be able to see 7 spots, okay? So actually, the chance of not being matched to the Mara Luna, that will be really low, okay? Because right now, you have 7 spots, okay, to confirm the result. Instead of one compound, one spot, only one spot to confirm what it is. So right now, you have 7 spots. At the same time, for the analysis of Mara Luna, by running those kinds of ingredient there, we will try to spray, okay, with the fast blue B as the visualizing reagent, okay, in order to visualize the spot, okay, on the TLC plate, okay. So actually, by spraying the fast blue B, so for different kinds of ingredient, they will be existing at different kinds of color. For example, for the CBC yellow, for the CBD that will be orange, for the THC will be red and then purple, and then with another orange, purple, and also red in color. So actually, not only 7 spots are there, so each of the spot, okay, they will be existed with certain kinds of unique color. So therefore, we have the retention factor together with the color, okay? So we have the 2 pieces of information to confirm what it is. So therefore, by using TLC for the analysis of the Mara Luna, that is not really in general we say as the tentative identification. If you now using TLC to analyze Mara Luna, that will be highly confirmative, okay? So that is one of the things, okay, you have to bear in mind. In general, TLC based on the RF value, that will be tentative identification. So that will be true, okay, for the other kind of drug. But for the analysis of Mara Luna, that will be in an other manner. So that will be confirmative. Because apart from the RF value, so we do have 7 RF value. At the same time, for each of the spot, okay, you will have a unique color there. So therefore, really, really confirm. Okay, so if it is really happen, then that is the Mara Luna. Okay. So for the other kinds of drug, okay, they will be just quite straightforward. Okay, for example, like when you look at the screen at the right hand side, okay, so there will be a non-cocaine, non-heroin, and then we have the non-methamphetamines. Then you have the unknown sample from the crime case, and you are just seeing those kind of spots, do they match, and then you will be identifying what are they. For example, that is another situation. We have cocaine standard, we have another standard, then the test sample, then you know, okay, so what are there. But bear in mind that for the drug, okay, after running the TLC, actually you won't be able to see those kind of spot there. Because for the drug, okay, they are a certain kinds of organic compound, they are colorless. So actually after running the sample, you have to put the TLC plates, okay, under the UV lighting, okay. So you have to put it under the UV lighting in order to be reviewing the fluorescence of the drug, okay, so that you could be able to see those kind of spots, okay. So that will be very important. If you just run the TLC and then you see nothing and then so nothing are there, actually you are wrong, okay. So you have to put it under the UV lighting, okay, in order to catch, okay, the fluorescence of the drug sample, in order to know where are the spots, okay. By comparing the RF value, the retention factor, then obviously you will be able to know what are they. So for the GC, okay, so as I already mentioned to you, we are seldomly using the LC to do so because most of the drug, they are thermally stable, they are volatile enough, okay, in order to gain the throughput of the analysis, as well as to be somehow more environmental friendly. Because in the GC, we don't need quite a lot of solvent. So GC, okay, will be commonly applied. That is the reason why I skip, okay, to write down the HPLC. So for GC, just a little bit reminder to you. So for each of the peat, it should be 1 analyte per peat, okay? So if you do not, okay, have a good separation of those kind of peat, or you don't have a good separation among different kinds of compound, So actually pit overlapping there, then your identification and the quantification will be suffer. So therefore you have to do something, okay, on the method optimization. So in order to really, each of the pit, it should be correspondent to one compound only. And then all those pit, they are well separatable without any overlapping. So if you still recall a little bit, okay, so from the separation science, actually by using GC, we can be changing the somehow like the GC column. So actually that will be the stationary phase, okay? You can be using, let's say, C18, okay? So that will be non-polar in nature, or it could be C8 or C2, or if you are now resolving some polar drop, maybe you are using the RESI column. So actually try to make use of an appropriate column, the polarity that is matching to the analyte that you are analyzing. The other things to help with the separation, that will be a temperature programming, okay? So we need a temperature program in order to resolve out the P, okay? Maybe at the very early beginning, we set a low temperature in order to let those kind of slightly retained species to be well separated. And then we then increase the temperature in order to letting those kinds of highly retained species to be eluted out in a reasonable retention time. Okay, so we try to set up a temperature program to do so. Isothermal condition may not be good enough. Okay, so that is the reason why that we need a temperature program. To avoid pit overlapping, we aim for a very small kinds of band broadening. Okay, maybe you can change about the carrier gas flow rate. So that will be the Van Dieter port. Okay, so we try to find out the optimum flow rate that we have the minimum height equivalent to a theoretical plate, so that the pit, okay, will be quite narrow. Or even you adjust, okay, your injection volume. Because of the injection volume, if it is too large, then you may be overwhelming your column. So if you really need, okay, a large volume of injection, maybe you have to tune up the speed ratio. Okay, so you need a split injection. So therefore, there are lots of things behind, okay, really trying to making sure that all the peaks, okay, they are being well separatable at the same time without any peak overlapping, so that each of the peak, they are corresponded to one kinds of analyte there. Then based on the respective retention time, then we know what it is, and then based on the peak area there, then we know how much they are. So therefore, one peak, okay, so one analyte, that is the most important message, okay, in GC. So that is the technique, okay, that we can use for the chromatography, okay, so under the drug analysis. So after we finish to talk about the chromatography, so actually we can talk about something related to the molecular spectroscopy. So for the drug, okay, so what we concern about, that is the organic drug, okay. Right here, we are not talking about any metallo drug. So if we have the metallo drug, okay, then we can be making use of the atomic spectrometry. But right now, the drug that we have been mentioned, okay, so let's say the opium derivative, the morphine, heroin, codeine, amphetamines, methyl amphetamines, ecstasy, cocaine, ketamine, or the THC, or even the LSD, actually they are a kinds of organic compound. So for this kind of organic compound, they are a kind of molecule that we can be using the molecular spectroscopy, okay, to deal with the analysis. So for the molecular spectroscopy, most of you, okay, learned it from last semester, okay, so for my course, analytical spectroscopy, and for the part-time year 2 student, you learn it somehow 1 year early on. So actually, we do have different kinds of technique, okay, to do so. So we can be making use of the UV visible spectrophotometry. We can be making use of the infrared spectrophotometry. We can be making use of the Fourier transform infrared, or even we can be making use of the Raman spectroscopy. So these are the 4 different kinds of techniques, okay, that we can use, okay, for the drug analysis, okay, so under the molecular spectroscopy. So for the UV visible, the idea that is quite straightforward. So we are now have the UV visible light, okay, shining through the curette containing the drug sample solution to see, okay, so what kinds of absorption are there. But one important message to you is, right now for the drug that we are talking about, they are organic compound. And for those kind of organic compound, almost all of them, okay, they are somehow colorless. So meaning that the absorption will be mainly at the UV region. So if you are now measuring something that is at the UV region, so make sure that the curette, okay, the sample container that you are using right here, that is made of cloth. Okay, if you're using the glass curette, actually nothing that you can do. So for the UV visible, we can simply measuring the absorption spectrum. So that will be the absorbance versus wavelength. Then we are going to see the absorption spectrum there. Then with the absorption spectrum, then obviously we could be seeing the absorption maximum, and we have the absorption minimum. So actually they are the points that we try to make use of it for the identification. So absorption maximum and also the absorption minimum. Okay, so this is the 2 kinds of parameter that we use. So in terms of the quantification, so actually all of you should know that. So actually you could be selecting one of the maximum, and then you will be seeing the respective absorbance by the use of the calibration curve of that will be the BSO, okay? Absorbance equal to the absorptivity times the powering times the concentration. So absorbance actually are directly proportional to the concentration. So quantification can be done there. For the UV visible, actually you have the sample solution in the curette. Okay, so after you did a measurement, you can just pull out the sample solution and then you can go for the next run. Okay, so actually that is the use of the UV visible. And for the infrared or the Fourier transform infrared, more or less they are the same, okay, as far as you know. We are measuring the mid-infrared absorption, okay? So the most important thing is for the traditional infrared, because of the weak light source, the weak detector, actually we cannot do anything on the quantification. But for the Fourier transform one, we are using the Michelson interferometer to be replacing the monochrometer. So we can measure all the wavelength at once, so that we have been improving the performance, so that the quantification can be achieved. Okay, so actually you know, okay, about the 2 difference here. So normally for the Fourier transform infrared or even for the infrared, we are measuring the mid-infrared spectrum, okay? So let's say that is the transmittance versus the wave number, okay? So still a little bit on the memory, okay? The x-axis, okay? So on the infrared measurement will be of the wave number. So different functional group, they will absorb a different wave number. So therefore, for a particular kind of sample, so for one kind of functional group, they absorb, and then another functional group, another functional group, so another functional group, another one. So actually, you will be seeing quite a lot of peak, okay, in the infrared spectrum, okay? And then most importantly, that is at the mid-infrared region. So if you still recall, okay, what I have been saying, okay, mid-infrared region, that is a fingerprints region. So different analyte, they will be showing up with a different mid-infrared spectrum. So actually that is a fingerprints uniquely point out to what kinds of substance it is. Because what you can be imagine is different kinds of substance, different kinds of compound, they should have different kinds of functional group there, okay? So that the mid-infrared spectrum will be unique to that, okay? So therefore, by using the IR technique, okay, we are going to making use of the whole mid-infrared spectrum, okay, for the identification purpose. And for the Fourier transform infrared, we can simply make use of the transmitting, or you can be converted to the absorbance. So just the negative log T, okay? So you could be make use of that, okay? So for the quantification there, okay? And for the IR technique, it will still be non-destructive in nature, okay? So for the solid, or even for the liquid, or even for gas, you can be get it back, so that they will be non-destructive, so that you can be performing another kinds of analysis later on. So for the Raman, okay, we are measuring the near infrared scattering. But for the near infrared scattering, what we know is for the scattering that is a Raman scattering, it is not only changing the direction of the light, it will also be changing the energy, okay, of the light. And the amount of energy has been stolen by the analyte. If you make a subtraction of the original wavelength towards the scattered wavelength, actually that will be the Raman shift. But for the Raman shift, what we can be say is that is falling into the mid-infrared region, okay? So therefore, for the Raman spectroscopy, although, okay, we are measuring the scatter light intensity versus the Raman shift. Okay, so that would be the Raman shift there. But actually, that is somehow the same as the mid-infrared spectrum. Okay, so that will be another way that we do, okay, for a measurement of the mid-infrared spectrum. So therefore, by the Raman, we still can be making use of the mid-infrared spectrum there, okay, although that is calculated by the Raman shift for the identification. For the quantification, simply we can make use of the scatter light intensity. So more analyte, they will be scattered more, less analyte will scatter less, okay? And for the Raman, that will be somehow an alternative approach of the IR, so that they will still be non-destructive in nature. So you can see, okay, by using the spectroscopic technique, so all of them, they are non-destructive. Okay, so you can be taking back the sample for the rerun. Okay, but most importantly, right here, what you can be imagine is by using the UV visible wavelength maximum, wavelength minimum. I will show you in the next slide. Okay, it may not be that confirmative. It will be tentative identification only. But for the mid-infrared spectrum, as I already say, that is the fingerprint region. So that is unique, okay? As it is unique, then the identification will be confirmative. So that is a confirmative identification there. So right here, just try to further show true, okay? So why using the UV visible, that will be the tentative identification. So most likely, you can be imagined for some compound that is of a similar structure. For example, the one that I showed you at the left-hand side. So with the morphine and the heroin, actually they are a kind of opium derivative. So actually they are having the similar kinds of absorption maximum and a similar kinds of absorption minimum. At the same time, when you are seeing with a caffeine, okay? So caffeine will also be showing a similar absorption maximum and a minimum at a similar region. So actually, after you have the wavelength maximum and the wavelength minimum, we don't guarantee that you really identify the unknown. So this one must be morphine. This one must be heroin. This one must be caffeine. Actually, we don't know, okay? Maybe we say that that is heroin, but indeed that is a morphine, okay? Because they have a very, very close, okay, absorption maximum and minimum because of the similarity of their structure. Okay, so therefore, also be a similar case, okay, for the TLC and the GC. So we may have some compound that are sharing similar kinds of polarity, so that they are getting out at the same or similar distance of travel or the retention time there. So right now, similar kinds of absorption behavior for a similar kind of structure. So the other problem coming from the UV visible, okay, so the UV, okay. So that will be the UV absorption, the UV visible absorption will be dependent on the solvent system. That means, okay, the solvent that you use, okay, to sustain, okay, your analyte will affect, okay, your absorption behavior. So on the screen, okay, at the right-hand side, so both of the absorption spectrum, they are corresponded to amphetamines. But one, okay, it is, let's say, in water. The other one that is in an organic solvent. So actually, you can see there is a shift of the absorption maximum and minimum a little bit, okay? So therefore, it will be quite difficult for us, okay, to really truly, okay, identify, to know, okay, so what it is, okay, because it may be having certain kind of shift, okay, depending on the solvent system. And then we are afraid that maybe we have certain kinds of compound of similar structure, they absorb similarly. So that's why, okay, for the UV, that will be tentative identification only. And for the infrared, that will be the confirmative identification. So just showing you two examples. So heroin, methyl amphetamines, obviously that is in the mid-infrared region, a fingerprint region, they will absorb differently, okay, because they have different kinds of functional group. Different functional group will absorb at different wave number, so that the whole infrared spectrum will not be the same. So therefore, it is unique, okay? So we don't have another kinds of compound that will share the same mid-infrared spectrum. So therefore, according to the mid-infrared spectrum, then there will be a confirmative identification. Okay, so maybe I give you a 10 minutes break first, okay, before I finish up with the mass spec, okay, for the drug analysis. So after I talk about the mass spec, then we will go ahead to talk about the forensic toxicology, okay? So maybe now we first have a break. Okay, so let's come back after the break. Okay, so can you still hear from me? Okay, so thanks for your reply. Okay, then I continue my teaching. So for the last 1 hour, okay, actually you have been learning how we can apply those kinds of instrumental analysis, okay, as the confirmatory test, okay, for the drug analysis. So I have been finished to talk about the use of the chromatographic techniques and also those kinds of spectroscopic technique, okay. So right now, what I to finish up that is the use of the mass spectrometry. So that will be simply the mass spec, okay? So mass spec, that will be the MS. So for the mass spec that we can use, okay, with the most simple one, that could be the ESIQ. So that is the electrospray ionization quadrupole, or it could be the Maudie-Torff, okay, the matrix assisted laser desorption ionization with the time of flight. So for the use of the mass spec, basically we are measuring the mass of the analyte, okay? So the mass spectrum that we obtain, okay, by using the mass spec, so basically that will be relative abundance, so versus the mass to charge ratio, okay? And then we will be seeing the parent speed, and then we will be seeing some fragmented iron, okay? Because for the mass spec, for the electrospray or even for those kinds of ionization technique, okay, they may be quite strong, okay? So that the analyte itself will be fragmented. But all in all, okay, in the mass spec with the parent mass here, so actually you can be imagine different analyte, different compound, they will have a unique mass, okay? So that is one of the important information. And for different structure throughout the fragmentation, that will also be unique, meaning that the fragment, okay, so of those kinds of smaller mass, okay, will also be unique towards the original compound. So therefore, by the use of the whole mass spectrum, okay, so not only the mass to charge ratio for the parent drug, actually with those kind of fragments, so we can be able to identify what it is. So basically for each of the mass spec, they should have the library. So subjected the mass spectrum into the library, obviously they will tell you what kinds of compound are there. So for the quantification, we will make use of the relative abundance. So that is the y-axis of the mass spectrum for the quantification. But most importantly, in order to achieve an accurate quantification in the mass spec, we need to apply the internal standard. Okay, so with the use of the internal standard, the quantification using the relative abundance will be much better. So for the mass spec, that will be destructive in nature, okay, because whatever you send in, you cannot take it back because it has been ionized, it has been fragmented. So no matter how you do, okay, you cannot recover anything, okay. But here, that is the use of the mass spec to deal with the drug analysis based on the mass spectrum. So basically, we will know what it is, and then by the relative abundance, then we will be able to know about the quantity. So basically, with the use of the mass spec, that will be quite straightforward to do so. So actually, here just showing you an example. So right now we have the heroin, okay? So heroin, we have the mass of the 369, okay? So that will be the original drug compound. But as I already mentioned, throughout the ionization, okay, that will be fragmented into different unit fragments. So we have the 327, okay, some part of it become broken, and then further broken to be the 268. And then for the parent one, they will have another kinds of fragment pattern, and then they will become 310. So actually, those kind of fragments will also be shown in the mass spectrum somehow uniquely. So therefore, by the use of the mass spectrum, we can be say that is a confirmative identification. Okay, but For those kind of details in the mass spec, I guess you have been learning from Ho Chai, okay, so no need for me to further recap it. But all in all, okay, the parent, okay, mass that is unique, and also the fragmented pattern that is also be unique. But by using the mass spec itself, okay, that will be good if you just have one active ingredient. One active ingredient, one mass spectrum, and then you don't have any worry that you misidentify what it is. However, imagine that if inside the drug sample, you do have two, okay, so active ingredient, okay. So for another ingredient, they show you another parent peak, and then they will be fragmented at different position, okay. So right here, I just draw it as the black color and the blue color, but for your mass spec, actually, it don't know. What the mass spec can sense, okay, 1, 2, 3, 4, 5, and 6. There are 6 peak, 6 mass to charge ratio there. Then subjected to the library, obviously, they will give you a wrong answer for the identity. So therefore, for this kind of situation, a single mass spec cannot give you any accurate result, okay? Then how we can resolve it? Either you can be making use of the GC mass, okay? So that will be the GC mass spec. So what it means is you now, okay, put the sample into the GC for some separation. So that will be the signal versus retention time. So one analyte and then the other analyte. And then as now, the detector is a mass spec. So that from the first peak, so you can be generate with the first mass spectrum, maybe that is the first one. And then for the second peak, okay, you could be able to generate the respective mass spectrum as well, okay? So maybe that is the second kinds of active ingredient. So therefore, right here, what you can be imagine is, you know, okay, by the GC, there are two ingredients, okay? So according to retention time, okay, tentatively, you know what are they. And further confirm with the respective mass spectrum, then actually that will be quite perfect. So therefore, with the GC mass, we can have the retention time together with the mass spectrum for the identification, okay? So obviously from the quantification part, so that will be the peak area issue. And then right now detector that is mass spec, so that will be destructive in nature. So that is the hyphenated technique, okay? So GCMS, okay, it will be somehow one step in advance of a single mass spec, because right now you could be have the power, okay, have the capability to solve out, okay, if you now have one more ingredient there, okay, so more than one, okay, if you just make use of a single mass, then you cannot get a correct result. You have to first separate it, and then, okay, so for each of the peak, so you will have the respective mass spectrum, then you will know it somehow truly. So apart from making use of the GCMS, you still can make use of the tandem mass spec, okay, to do so. So that will be the MSMS. So what I mean is you make use of the first mass spec, okay, to measure the respective mass spectrum. Then finally, you try to make use of the second mass spec to analyze, okay, so some of the parent peaks there. For example, you take out this peak, okay, to run for the second mass spec, okay, then you will be able to see the spectrum right here. And then you may try to take out this peak, okay, to run for another mass spec, okay. So obviously you will be seeing another mass spectrum. So therefore you still can be able to see the individual mass spectrum of each of the compound, so that you can be identify it accurately. So therefore making use of the MSMS would be another kinds of tools that can be help you to solve, okay, with a mixture of drug. So based on the MSMS, so you make use of the mass to charge ratio from the first mass spec, and then you make use of the mass spectrum from the second mass spec, okay, so for the identification. And then mass spec only right here that will be relative abundance for the quantification. Mass spec by default, that will be destructive in nature. So here actually give you all the things, okay, that we need, okay, for a drug analysis, especially for this lecture, okay. So up till now, okay, I have already showed you all the techniques, okay. So chromatography, molecular spectroscopy, and mass spec, okay. How we can use it, apply it, okay, to identify what kinds of drug it is, as well as we have to quantify how much are there. So because at the very early beginning, we mentioned that if it is the illegal drug, okay, the amount, okay, will affect the penalty. So small amounts will be 重毒, so large amount will be 贩毒, okay, so the sentence, okay, will be different, okay. So that is what I want to share with you for this lecture material. So any questions or problem at this moment before, okay, we go to another topics. So at the same time, okay, before I go for another topic, I have to erase, okay, all the things on the whiteboard, okay. So therefore, please take some second, okay, to copy it down, or you try to take a capture screen. Okay, so no question. Then I will erase the whiteboard. So last 5 seconds. Okay, then we move to the next lecture material. So that will be the forensic toxicology. Okay, so let me put down the topic. Okay, so right now we start to talk about the forensic toxicology. So for the forensic toxicology, what we try to be focused, so that will be something that is toxic, okay? So if something that is toxic, we say that that is a poison. So therefore, the crime cases that we are interested in would be the poisoning cases. So right now, it will be quite different, okay? So from the drug analysis. So mainly that is for the drug analysis, so we have the drug sample somehow on hand, then we analyze the drug sample. So what are they, what kind of quantity? So that will be the drug sample itself. But right now for the poison analysis, okay, because of the poisoning cases, the poisons has been taken, okay, by the victim. Okay, so either orally taken or you go through the injection. So the poison now that is getting into someone's body. So we have to analyze someone, okay, in order to know, okay, where are there any poison? So if they are, then how much are there? Then we try to see, okay, whether these kinds of cases is a poisoning cases or not. So therefore, the analytical approach will be quite in a different. So using drug as an example, drug analysis will be quite simple. But for the poison analysis, okay, inside someone's body, we have to making use of the biological sample, and then they will give you quite a lot of trouble, okay? But all in all, okay, in the forensic toxicology, we will first give you the definition on what is poison, and then give you a little bit background information before we go through the whole stuff of the poison analysis, okay? But basically, we still need to go through the screening test, sample pre-treatment, confirmatory test, and also the retest. Okay, so let's get started. So the first thing that we want to pay attention, okay, so inside the forensic toxicology, so that is the poison. So what do you mean by poison? So by definition, poison is any substance that is used to cause disturbance in humans, okay, or even for any kinds of living organism. So right now, the terms that I use, that is to cause, okay, disturbance, okay, somehow that will be a negative effect, okay. So that is quite in an opposite, okay. So for as a drug, okay, by itself will give you some enhancement, but for the poison, okay, the intention of using a poison is to cause you disturbance. So let's say try to hurt you, try to cause you injury, or even try to kill you, okay. So that is the use of the poison, okay. So with the poison being used to someone, okay, actually there will always be a negative effect, okay. But in the world, okay, there is nothing, okay, not to be a poison, okay. That is really important, because whatever in the world, it could be a poison. The main difference is the dosage, okay. So maybe some of the stuff, okay, you look, it is not a poison. For example, like the water, okay. So water, it is quite good for health, but it could be a poison if right now you ask, okay, someone to drink 10 liters of water in 1 minute. Okay, so 10 liters of water in 1 minute. Actually, if you drink a lot of water within a very, very short time, actually your whole body will be being diluted and actually you will die. Okay, so therefore, really, okay, you can be say, okay, nothing in the world that is not a poison, just depending on how much, okay, you treat, okay, to someone. So for some of things, it is really, we say that toxic, meaning that small amounts will be good enough. For something that is, we say that that is non-toxic, okay, meaning that you need a lot, okay, but all the things can be a poison. So therefore, in terms of the poison analysis, the scope, it is much, much, much wider than the drug analysis. For the drug analysis, we have been defining that for this kinds of compound, for this kind of substance, they are drug. But now, okay, we have been expanded that everything, okay, so everything, okay, could be a poison, okay, depending just on the dose. Therefore, in the poison analysis, it will be no trouble that we have to identify what are there in the victim's body. At the same time, we have to quantify how much are there before we can really judge, okay, so which of the substance caused the problem, okay, to the victim. So when we try to compare different kinds of poison, okay, actually we have two important parameters there. The first parameter that is related to the threshold, okay. So the threshold means to be the minimum amount, okay, that the substance will give you the poisoning effect. So we do have something that we say that that is the no threshold poison. So once it presents, then you will have the effect already. So some of it, we say that that is a threshold poison, meaning that you have to subject to be with a sufficient amount, okay, before the effect will come. Okay, otherwise our body can be sustain it. Okay, so actually what you can be imagine is if now some people has been treated with a small amount, just a little bit above the threshold, actually the victim will not be killed, okay, somehow immediately, but the effect, okay, will be accumulated for a long time, so that above the threshold a little bit, okay, maybe we will be seeing a long-term poisoning cases, okay. But for another situation is if you are treated someone with a high enough dose, okay, so let's say we are using a term called as the LD50. So that is the latent dose 50. So that will be the amount that 50% of the population will be killed and 50% of the population will still be alive. So actually it is really a high percentage that half of the chance, okay, you will be survived, and half of the chance you will be alive, okay. So actually, that will be really high enough. So if someone has been treated to the, let's say, LD50 or even higher, so actually the effect will come somehow within a short time or even immediately, then will be leading to a short-term poisoning cases, okay? So actually, by the dosage, at the same time, low dosage or high dosage, any effect there, actually we will have a different kinds of poisoning cases. But finally, what we try to draw on a conclusion is it really a poisoning cases? So if it is a poisoning cases, so what kinds of substance it is responsible for the poisoning? What kinds of amounts there? And if at last, okay, we want to catch, okay, the guy, okay, who subject the poison to the victim. Okay, so that is the whole things that we want, okay, to be solved in the forensic toxicology. So here shows you further information related to the Levenzold. Okay, so that will be the LD50. So most likely the LD50, just for your information, so we will have the unit for the milligram per kg. So milligram, that is the amount of substance that you need, and then kg, that is the body weight of a person or an animal. So if we treat it like a normal adult, then we can make use of 70 kg. So that to convert, okay, to the milligram that we need, okay, for the LD50 there. So actually what you can be see right here, we could have something that is highly toxic. For example, like the botulinum, okay, so 肉毒桿菌, dioxin, ioying, or even we could be seeing some pesticide, and then cyanide, there will be cyanide, and then we will be seeing some table salt, vitamin C water. Actually, there could be a poison if you are be subjected with a sufficient amount. So this is still, okay, coherent to what I have been saying. The dose, okay, will make a poison, okay? But you could be imagine that in most of our case, okay, we won't be seeing using water, okay, to kill someone, okay, because you really need a large amount. So in order to kill someone efficiently, okay, so actually, or in order to hurt someone efficiently, okay, so actually by using something that is highly toxic will be better. So therefore, although, okay, we say that in the world, okay, we have all the things to be poisoned, but the scope, okay, will be somehow quite focused, okay, on the area that those are the things of highly toxic, okay. Unless, okay, you cannot find any, then you have to expand your scope. But otherwise, most of our focus will be on the things that is highly toxic, okay, will be the one that we suspect. So in general, the poison could be classified according to the respective form in the ambient condition, okay? So ambient condition will be as the normal atmospheric pressure and the room temperature. So that will be the new classification just according to the respective form in the ambient condition. So in the olden day, the poison could be classified by the corresponding action, okay, so on the human. But if you classify by the action on human, actually nothing in the world that is not a poison. So actually that will be quite scary that you will be seeing hydrochloric acid is a poison, and then sulfuric acid is a poison, or even for certain kinds of metal salt, it will be a poison. So actually it will be very hard for a differentiation what is really a poison. So therefore right here, we just try to be limited our scope, okay, to be those kinds of highly toxic one, okay? And we try to classify them according to the respective form in the ambient condition right at this moment. So for the form, okay, obviously we can have the gas poison. So for the gas poison, one of the quite common kinds of poisoning cases will be the carbon monoxide. So 一氧化碳. So for the carbon monoxide poisoning, there will be two kinds of situation. So either that is to commit suicide, okay, so someone burning charcoal inside the, his or her room, okay, so somehow in the closed environment. So in complete combustion, burn out carbon monoxide, he or she breathe in the carbon monoxide and then die, okay, so there will be quite an obvious situation to commit suicide. So the other kinds of cases for the carbon monoxide poisoning will be the accident, okay? Because let's say in the North America or even in the Northern Europe, so in the winter time it is really cold, okay? So some people will set up some fireplace, okay, to burn out the wood, okay, in order to take the fire to keep warm. But they are not be aware that the whole apartment or even for the whole house, okay, has been closed all the window, and then still be the same cases in complete combustion carbon monoxide, and then the whole family die, okay? But the difference between to commit suicide and an accident is to commit suicide, okay, the guy, okay, has the intention to do so. For an accident it is really an accident, okay? So the guy, okay, didn't realize that, okay, it will be a problem, okay? But why carbon monoxide can kill someone? So mainly is carbon monoxide will bind to the hemoglobin tightly so that we cannot carry out any oxygen anymore. So that we will be somehow breathless, okay? And then we cannot utilize oxygen. Without oxygen, and then that will be in a great trouble, okay? So with the carbon monoxide poisoning, obviously you will be seeing those kinds of victims, okay? They will say to you, I can't breathe, okay? No matter how hard I breathe, okay, I still cannot obtain the oxygen, I cannot breathe, okay? So that is what they say. So this is one of the symptoms that you will see. The other things that you can be see, okay, with the carbon monoxide poisoning, that is the skin color will be of a cherry red, okay? Because the carbon monoxide binded to the hemoglobin that will have a unique red color. So that is a cherry red color. So therefore, it will be another observation, okay, to say, okay, so carbon monoxide poisoning. But not trying to see the victim, okay, by seeing the whole places of the crime scene, you will know whether that is a carbon monoxide poisoning already. So when you get into someone's apartment, all the window and door are closed, and then we have a burning charcoal inside, someone died next to it, obviously carbon monoxide poisoning, okay? So apart from the gas, okay, of the carbon monoxide, so the other kinds of poison that we can have, that is the volatile organic poison. So they are volatile enough that can be exist as a vapor. So for the most common one that we still can find in the world could be some nerve gas, 神經毒氣. So one of it maybe is quite famous to you, maybe this is the sarin gas, the 沙林毒氣, because it is a very famous incident in Japan in the 90 something, okay? So 沙林毒氣, okay, has been released, okay, in the underground of Tokyo and then kill someone, okay? So why, okay, those kind of nerve gas, they are quite poisonous? So mainly because, okay, when you breathe in the nerve gas, your lung cannot function normally, okay? Your whole lung, okay, will be just being contracted, okay? Without the movement of the contract, relax, contract, relax, contract, relax, actually, you cannot breathe in air. So therefore, right at this point, okay, the question is, you cannot breathe in anything anymore, then you will be suffocated, okay? You cannot take out oxygen, your carbon dioxide inside the body cannot breathe out, so that you will die, okay? So by seeing for the nerve gas poisoning, basically you can check with the guy, can you breathe, okay? Then you will see, okay, he or she cannot breathe anymore, the whole lung has been contracted, then obviously you know, okay, it could be the nerve gas poisoning. So in the poisoning issue, we now can come over with the metallic one, okay? Because when we talk about the drug analysis, we always have the organic drug only. But right now for the poison, it could be expanded to the metal. Because we could have the heavy metal as the poisoning substance, but we do have some kinds of famous or common kinds of heavy metal to be used. For example, like the arsenic, okay? So the one that we are afraid of, that is the arsenic-free oxide. So in Chinese, that is the pei sheng, okay? So for the arsenic-free oxide, mainly it will be disturbing the energy production, okay? So inside your body, so that you will be always feeling tired. At the same time, when it get into our body, it will be just dissociate to forming some reactive oxygen. So the first place that come with the arsenic will be the stomach. Okay, so you take in arsenic and then there will be the stomach. So therefore, we have a lot of reactive oxygen in the stomach, then it will be leading to the stomach problem. Maybe we have the stomach ache, or right after you may have the stomach cancer. So therefore, when someone that is suffer from the arsenic issue, basically check with the stomach. So if we can see, okay, the victim are having some stomach problem, maybe that is the arsenic issue. So for the other kinds of metallic poison, it could be the mercury. So for mercury, it may be an accident because of the deep water fish, okay? So mercury 0, that is the metallic mercury, or even the mercury 2+, or even we have the organic mercury, okay? So with the intake of the mercury, let's say accidentally, so we will have the muscle problem, poor coordination, and then your hand and feet, okay, you will have some lumps, okay? But right here, by using the mercury as the example, basically I want you to pay attention that different species, okay, they may have different toxicity. So metallic mercury, highly toxic, mercury 2 iron, a little bit less toxic, and for the organic mercury will be less toxic. So therefore, if you are now analyzing the metallic poison, you cannot just measure the total metal content. Please pay attention to the species, okay? Otherwise, you will misjudge, okay? So what kinds of poisoning effects are there? Also be the case for the arsenic. Arsenic, what we concern, that is the arsenic-free oxide. But we do have the arsenic 5 oxide. So arsenic 5 oxide will be less toxic. So therefore, speciation, it is really important, okay, if we are checking for the metallic poison. The other kinds of metallic poison that we may face nowadays, that could be the radioactive poison. For example, like the plutonium-210, or even for the nickel-63. So they will have the radioactive property. So therefore, they are a radioactive substance. If it just get into your body, then you can be imagine you have the alpha, beta, gamma ray just emitting inside your body, damaging all the stuff inside, and then you will be killed, okay, so quite easily. But right here for the radioactive things, that will be the isotopic issue. So it has to be plutonium-210, it has to be nickel-63, okay, because nickel, nickel, you can have another kind of isotope. Let's say you can have the nickel-60, so nickel-60, that is the original one. So therefore, there is an important message that you have to deal with the isotopic analysis. Okay, that will be the responsibility for the ICP-MS. If you cannot measure the isotope, then how you can be concluded that may be a radioactive substance. Okay, so therefore, for the analysis of the metallic poison, there are lots of interesting things, okay, that we need to pay attention. Speciation and also the isotope there. So for the organic one, apart from the vapor, okay, we still can have the non-volatile organic poison, okay? So it could be, let's say, cyanide, okay, so that will be cyanide. So cyanide will leading to some heart and lung problem, okay, because the major problem that happen in our body is our cell, okay, cannot respirate anymore because it will be just having some inhibition of the enzyme, okay, inside the mitochondria. So that, okay, your body will be sense that your human cell, okay, are lack of oxygen. Then we'll ask the lung, okay, in order to breathe in more, in order to take up more oxygen. Ask your heart, okay, to be somehow heartbeats, okay, will be much faster to pump the blood, okay, to the cell. But actually, it is nothing related to how you pump the blood or how you breathe in, because it is being hurt, okay, by cyanide. But once your lung and the heart has been overloaded, then actually you're leading to such kind of problem. So therefore, for the cyanide issue, heart and the lung diseases could be one of the clue, okay, for you to somehow to be safe, maybe cyanide. For resin, that is PEMA, okay. So for PEMA, that is an very toxic compound because it will inhibit the protein synthesis in your body. Okay, it will be just attached to your mRNA, then you cannot synthesize protein anymore. And then with the resin, actually there is nothing that you can be help with you. because without protein, you will be suffer a lot. For example, for your immune system, okay, so that is antibody, so they are protein, or even for your blood, the hemoglobin, they are protein. So therefore, your whole body will be very, very weak, okay, if you are suffer from that. For the dioxin, that is ioxin, so that is a carcinogen. So with the intake of the dioxin, basically inside your body, that will be leading to a various kinds of cancer, okay? Maybe at the same time, you will be facing the stomach cancer or lung cancer or even kidney cancer or even, let's say, the whatever kinds of cancer there, okay? So therefore, if you are finding the victim that are suffering from a lot of cancer at the same time, then it may be the dioxin issue. So we still, okay, for the organic poison, it could be the normal drug poisoning or even the alcohol poisoning, okay? Because for the alcohol poisoning, it doesn't mean to be you drink a lot of ethanol and then you cannot perform well or you are being died with drinking ethanol. Maybe that would be a drunk driving issue, okay? Because if you drink alcohol, you cannot drive, okay? So it will also be falling into the forensic toxicology part, okay? So therefore, right at this point, with this kind of brief introduction, okay, so for the gas poison, the carbon monoxide, the nerve gas as the vapor, different kinds of metallic poison, or even for the non-volatile organic poison. So actually, just showed you a certain kinds of background information, okay? So that is somehow what we have been done, okay, for the drug analysis. So introducing you some background, okay, so if somebody has been suffer from whatever kinds of poison, so what kinds of effect, what kinds of behavior they are, actually that will be important to help us to narrow down the number of possibility. Because right now, for the drug, okay, so there will be just a tiny group, but for the poison, it could be all the things. So therefore, we try to make use of the background information, seeing the behavior, seeing the syndrome, seeing the effect, okay, so from the victim, in order to help us to narrow down the number of possibility. So try to narrow down a bit, okay, otherwise there will be 大海撈針. We never know what happened. We can never know how we can set up an appropriate protocol. Okay, so now, okay, we get into the topic, okay, so the definition of forensic toxicology. So by default, you know, under this topic, we try to make the poison analysis. But most importantly, our objective is we try to apply the toxicology knowledge into the court law. So mainly, as I already mentioned, we try to see whether the crime cases, whether it is a poisoning cases or not. If it is, so what kinds of poison has been applied, and is the dosage sufficient to cause those kind of effect? So that is our objective. So what we do is we try to analyze the poison, so inside the victim's body. So that is the reason why we need to take the victim, okay, and then to take up some biological sample. So either we take up some blood, take up some urine, or even if he or she is died already, maybe we need to take some organs, okay, in order to conduct the poison analysis. So at last, okay, basically based on the identification and the quantification that we done, then we draw on a conclusion. So that is somehow the whole stuff, okay, for the forensic toxicology. So in terms of the difficulty to conduct the poison analysis, we are facing a lot of problem, okay? Because most of the time, okay, we are not having any kinds of clue, okay, to know what kinds of poison are there. So if you are quite lucky that you are dealing with the carbon monoxide poisoning cases, so when you get into someone's room, okay, you can see door closed, window closed with a burning charcoal. Obviously, you have a clue, okay? Or right now, you are getting into a scene that, so next to the dead body, you find a bottle of alcohol and a bottle of barbiturates. So you know it is a suicide cases. But most of the case, okay, will not be that straightforward, okay? Because in order to kill someone, actually we try to make use of something that is highly toxic. So highly toxic means that, okay, the amounts that you use will be quite tiny. Okay, so with the tiny amounts of poison that we use, okay, actually it is hard for you to detect anything. At the same time, if the amount, okay, it is not really high, but it is good enough as a massive dose already. So some of those kind of negative effect, okay, is not yet arrived. The person has been killed already. So actually, we won't be able to have such kind of background information. So therefore, it will be a problem without those kinds of effect, without those kinds of information, tiny amounts, okay? And then it will be very hard for us to solve the case. At the same time, tiny amount, it is one of the signs. But those kind of tiny amounts, they are inside the victim's body. So right now we have the biological matrix. Okay, so from the blood sample, urine sample, even from the organ, actually you will expect a very severe matrix effect. Okay, so with the matrix effect, what you can be imagine is the signal will be underestimated a lot. Okay, then actually you may have the underestimation for the whole situation. So therefore, we need, okay, a very sensitive technique to do so. At the same time, we need to perform a very rigorous sample pretreatment, especially a very, very rigorous extraction in order to take out the analytes away from the matrix. Otherwise, we will always be suffering. So another thing is we cannot just be happy. So we can find one poison and then the case closed already. Actually, as I already mentioned, in the world, all the things can be poisoned. Okay, so therefore you have to detect all the things, okay, before you can really draw up a conclusion. Okay, it cannot be just one single measurement, one single scheme. You find one poison and then you are happy and then case closed. Okay, actually you have to do a comprehensive analysis. Okay, to really know, okay, what are there exactly. Okay, and then you are be able to draw the conclusion later. The other things that you may want to be aware, so now the poison has been get into someone's body, so it will not be the original form, okay? Because when you take in some poison, so our body that is quite clever, okay? So that is something toxic, so it will be sent to the liver to go through some metabolism for the detoxification. So therefore, the poison itself, okay, will be changed, okay, to be some metabolites. Okay, so therefore inside your body, it doesn't be the poison itself. It could be the metabolites together. So once, okay, the time has been go forward, most of the poison will become metabolites. So therefore, if at the time that you try to analyze, you just try to analyze the poison only, actually you will find zero. And then you may be drawing a wrong conclusion. So therefore, for the analysis, you have to add a lump sum of the poison and the metabolites together in order to have a full picture. But what happened is you now have the poison, you now have the metabolites, they are really somehow circulate or accumulate at different part of the body. So therefore, the actual concentration inside the body will be even lower than what you expect. So therefore, for the poison analysis, that is a key message that it is really, really difficult, okay? For the drug analysis, it is really, really easy, okay? So for the poison analysis, we have to go through a lot of things rigorously. Otherwise, we cannot be able to get a correct result. So now, okay, before we can really conduct the analysis, we have to get use of certain kinds of sample, okay? So therefore, we first talk about the sample, okay? So for the sample, as you can see, okay, we can have different kinds of sample because right now you can be imagined is now the victim has been already taking some poison, or now the victim has been injected for some poison. So therefore, the poison will be just at around the whole body. So therefore, the whole body, different kinds of body fluid, different kinds of organ, actually they can be used for the toxicology study. But which of the sample or which of the body fluid or which of the organ that is the best, okay? Actually, we have to think about that. In order to think about which one that is the best, okay, there are 4 different criteria for you to think about. The first one that is related to the objective, okay? So what kinds of objective are you talking about? Mainly, okay, if we are saying with the objective that we are trying to differentiate whether that is a short-term poisoning issue or that is a long-term poisoning issue, okay? So the kinds of sample that we need will be different, okay? So short-term poisoning or long-term poisoning. So the other criteria that is related to the relevancy. So in terms of the relevancy, we try to say whether we want a identification or we also want a quantification. Some of the sample, okay, you can be dealing with the quantification, but the quantity that is meaningless, okay? So do you need both information? So that will be the relevancy. So the other one, it is the types of poison that you want to analyze, okay? What I mean is you are analyzing the poison itself, or right now you want to analyze the metabolite, okay? So that will be somehow you need to think. The other thing will be quite practical, okay? So that will be the availability. So is it still available, okay? So from the victim, because you can now have the person still alive versus the person, the victim has been killed, okay? So actually the types of sample that you can take will also be different. So these are the 4 criteria that you need to think about before you really select, okay, which kinds of sample, which kinds of body fluid or which kinds of organ that you need. So before letting you go, okay, let me take you somehow around 5 more minutes, okay, to talk about 1 to 2 body fluid that we can use. So the first kinds of sample, okay, that I want to discuss with you that is related to the blood sample. So blood sample that is the primary specimen in the forensic toxicology. So mainly because it's the concentration of poison in the blood that is really closely correlated to the dosage. So why it is really correlated to the dosage? Mainly because if you take the poison orally, so they will be just get into the stomach, stay there for around 2 to 3 hours, and then it will just go through the intestine, and then those kind of poison will be absorbed. Okay, so once the poison has been absorbed, then they will be just transferred, circulate around through the blood system. So therefore, the amount, okay, inside the blood will be really correlated to how much you have been taking. It will also be the same case as if the victim has been injected for the poison. So injected through the muscle, it absorbed, and then they will be just circulate around through the blood. Okay, that will still, okay, be related to the amounts there. So therefore, by using the blood sample, obviously you can identify what are there, and at the same time, if you perform the quantification, you can be able to know about the dosage. So whether the dosage is high enough or low enough. So therefore, the quantity that will be meaningful. And as you have already heard from me, okay, the blood sample will provide the information that the subject was affected at the time of collection. So what it means is you take in, and then after around 2 to 3 hours, it will be just appear in the blood, okay? So therefore, it will be related to a short-term poisoning issue because you can be seeing those kind of poison after around 2 to 3 hours. So therefore, it will be really within a short time. So for the poison that we can find in the blood, at the very early beginning, that will be the poison itself. Okay, basically, once it is being absorbed, that will be the poison. But as the time go forward, okay, so some of the poison will be sent to the liver, so for the detoxification, so that later on you will be seeing some metabolites there. But at the very early beginning, most of it or almost all of it, they are the poison itself. And to take the blood, okay, so obviously you make use of a syringe, in order to withdraw from the victim's body. And then you take out around 10 ml will be good enough. Put it into the renal jet tube and then add some preservative to avoid the blood has been caught. Okay, then it will be somehow you can use it for the further poison analysis. But right now, what you can be imagine is the person, okay, should be alive. Okay, if you really want to take out the blood sample, okay, because for a dead person, he or she, the blood stop running, caught already, dry already, you cannot take the blood. So therefore, for the alive person, you can take the blood quite easily. Okay, so with the blood, it is a very good sample, okay, to do the toxicology study, because the poison will be appear really within a short time, and then quantification can be done there. At the very early beginning, all of them are the poison, no need to bother with the metabolites. And then once it is a alive person, and you can get the blood sample. So the other kinds of sample that we can play with that is related to the urine, okay? So for the urine sample, you can be just provided the victim with the glass vial, and then ask the victim to go to the washroom, and then you can be able to collect the urine quite readily. So therefore, the victim should be alive, okay? Otherwise, he or she cannot go to the washroom, okay, in order to get out the urine. So for the urine, basically, it will take around 8 to 6 hours in order for you to detect the poison. So mainly because now you can imagine you take in the poison, go through the stomach, absorbed by the intestine, and then go to the liver for the detoxification. Those kind of metabolites, they are a waste. Then they will be transferred to the kidney, and then the kidney will be extracted out, go through the bladder, and then they will be excreted through the urine. So therefore, the process will be take around 6 to 8 hours before you can really go for a detection. But for 6 to 8 hours, it is still for a short-term poisoning because it is within a day, okay, within a short time. But right here, what you can be imagine is only metabolites, okay, can be detected, okay, because our body cannot be excrete out the poison. You have to go through the detoxification and metabolism to become metabolites before you can go through the excretion. The other thing is for the relevancy identification only, because for the excretion, different person will have a different excretion rate, and different person, they will have different metabolic rates as well. So that the amount, okay, can be seen inside the urine will not be related to anything, okay, because you don't know how much have been subjected, because the amounts that we can see is if someone having a very, very fast metabolic rate, very, very fast excretion rate, then you will be seeing more. If for someone that are having very slow metabolic rates, very slow excretion rates, obviously you will be seeing just a few. So therefore, the amounts there will be meaningless. But we still can perform the quantification to see whether it would be certain kinds of circumstances that we can see a lot, okay, in the urine. If you can see a lot in the urine, meaning that the original dosage should not be low, okay, but from the urine, if it is quite low in the concentration, then we can draw no conclusion, okay. But if in an extreme cases, we are assuming that a lot in the urine, that means the dosage will be a lot, okay, a direct correlation there. So for the urine, not only you can detect after 6 to 8 hours, actually just depending on the excretion rates of different person, you can be able to detect the poison, let's say up to 2 weeks, okay. So therefore, still okay be a day, okay. So it will still be lasting regarded to be as the short-term poisoning only. So I believe, okay, time is running out, then I will stop talking for today. Next time when we come back, okay, we will start to talk about the hair sample. Okay, so hair sample will be used for the long-term poisoning cases, and I will still be talking about something further. Let's say how we can make use of the organ for the sample as the forensic toxicology study. So just seeing all of you next Tuesday. Okay, so thanks for attending today's lecture, and then see you all next week. So I will still stay here for 5 more minutes. So if you do have any questions or problems, just stay behind.